In this video, we are going to be looking at inductors, to how they work, where we use them, and why they are important. Hey YouTubers, remember, if you subscribe, you're always at the front row of the physics show. The inductor is an electronic component capable of storing energy. Battery can store energy by chemical reactions, and capacitors store energy by generating an electric field. The inductor does not use either of these options, but stores energy in the form of a magnetic field. How does inductors store and release energy from the magnetic fields they generate? That's a good question. When we connect an inductor in parallel with a resistive load, such as a lamp, when we power the circuit, the electrons are going to first flow through the lamp and power it. At first, very little current flow through the inductor because its resistance is too large. Resistance will reduce and allow more current to flow. Eventually, the inductor provides nearly no resistance, so the electron take this path to flow back to the power source, so the lamp will turn off. Let's look at what happens when we disconnect the circuit. The inductor is going to pushing electron in a loop through the lamp until dissipate its energy. So now we are at the point. Let's come with me and find what's happening in the inductor. When we pass electrical current through an inductor, it will generate a magnetic field around it like this. So in the circuit, when the current will begin to flow through the coil, the magnetic field also begin to form and increase up to its maximum. The magnetic field storing energy. The energy stored in an inductor can be converted back to electrical energy when the current through the inductor decreases or stops. When we disconnect the circuit, current will decreases. As the current decreases, the magnetic field collapses, and the energy stored in the magnetic field is released. This released energy is then converted back into electrical energy, which can be used to power the lamp connected to the inductor. What is the physics behind this? When the current changes, the magnetic field around the inductor changes as well. But inductors doesn't like to change. They want to remain same. That's why when the current increases, they try to stop it with an opposing force as well. When the current decreases, they try to stop it by pushing electrons. This is the magic behind the inductor. Now it's clear why the inductor behaved like this. So, what we use inductors for? We use them for transformers, motors, and relays. We can use them to filter the frequencies, and we use them in boost converters to increase the DC output voltage. That's all for today. I hope this video is helpful for you, at least interesting. If true, give the support to the channel.